Welcome and good morning. Presenting to you from the Krembil Research Institute at the University Health Network, we acknowledge the land we are meeting on is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabeg, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis peoples. We also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit.
The Durham District School Board acknowledges that many Indigenous nations have long-standing relationships, both historic and modern, with the territories upon which our school board and schools are located. Today, this area is home to many Indigenous peoples from across Turtle Island. We acknowledge that the Durham region forms a part of the traditional and treaty territory of the Mississaugas of Scugog Island First Nation, the Mississauga peoples, and the treaty territory of the Chippewas of Georgina Island First Nation. It is on these ancestral and treaty lands that we teach, learn, and live.
Welcome, everyone, and thank you for being with us today on this International Day of Women and Girls in Science, which was first introduced by the United Nations in 2016 to address the growing gender inequality in STEM fields. This is a really important day, and it's wonderful that so many of you came out to support this initiative. It's going to be a lot of fun. The truth is that science needs everyone with passion, ambition, and curiosity, girls and boys alike. But for the girls and young women in particular, we clearly need to entice more of you into this field. Currently, less than 30% of scientific researchers worldwide are women, and only about 30% of female students choose to do graduate school in STEM-related fields. As for my own story, I came to Canada in the last year of high school. As a new immigrant, I had a lot to learn about in a short period of time and adapt to a new world, new culture, new climate, new everything. However, I saw my move to Canada as a tremendous opportunity, and despite many factors telling me I couldn't, I truly believed that I could, and I had a lot of hope. I knew my move to Canada had potential, and I had ambition, and I wanted to see where it took me. I never thought about what I wanted to do, nor really knew at the time where I would end up, but I knew I wanted to do something special in the areas I enjoyed and loved, which was math, science, engineering, and ultimately medicine. When I became a neurosurgeon, a brain surgeon, I was one of very few females in the role. I still am. Only about 10% of neurosurgeons in Canada are women. But I'd like to see that change, and I hope that many of you in the audience would consider this as a profession, because in my opinion, this is truly one of the best jobs in the world. There is no comparison. I'm also a senior scientist and I do research, and so I split my time between treating patients with brain cancer and trying to understand the mechanisms behind the disease. What causes a cancer to grow? What causes it to respond to treatment? And more importantly, how can we try to stop it so that I can help the patients that I deal with and to give them better, fuller lives? Today's event is all about helping you to understand what makes science such a fun and rewarding career for everyone. And even if you're not interested in a career in science today, or if you're not sure, it's still really important that you know what scientists actually do so you can support their work. I am very fortunate to work with many incredible women at the Krembil Brain Institute. And today you are in for a treat, because we're going to learn about what they do, why they do it, and how they do it. Ultimately, today we hope to leave you with the understanding that science isn't boring. It's quite the opposite. Science is about solving problems and answering questions. Sometimes those discoveries can lead to new treatments or even cure for disease. Can you imagine anything more exciting than that? Let's watch this video.
Science isn't just microscopes and neurons and bacteria. It's a way of asking questions.
We are training the system to find a new path between the muscle and the brain.
Everyone has some connection to cancer. We need to find a way that we can prolong their life and give them hope.
Studying regeneration or using cells to fix broken hearts, that is something very new.
The brain is vast, the brain is complex. You want to kind of crack that code.
So what if that was a pandemic and the virus spreads really fast? We are predicting the future.
I was always interested in robotics. I love using technology to improve someone's experience.
Science is curiosity, and science is wanting to know more about the world. It's fun.
Hey everybody, I'm Mayim Bialik, and you may know me as Amy from The Big Bang Theory. But what you may not know is that in real life, I have a PhD in neuroscience from UCLA. And events like this one are so important because we need to get the word out to young people, and girls in particular, that being a scientist is literally one of the greatest jobs in the world. Imagine going to work every day with an amazing question, working on every possible scenario, and one day possibly finding the answer. It's not enough to tell young girls and women about the benefits of working in STEM fields. We have to show them by example, which is exactly what Krembil's education efforts are all about. You're going to hear from some incredible women today who've made science and medicine their life's work. I hope that their personal stories will amaze you and inspire you. My message for today is that science is for everyone, especially you. It doesn't matter where you start in life, what your circumstances are, science needs you. Go forth, make magic happen, follow your dreams, and let science lead you there. Bye-bye.
Let science lead you there. I love that. Well, I am certainly inspired by Mayim's message. I hope you are too. Now, I would like to introduce you to the amazing Dr. Mosh Gan Hudai, also a neurosurgeon and a scientist at Krembil Brain Institute, part of University Health Network. Here is her story.
When I was growing up in Iran, it was a very early part of my life. I lived there only until the age of 9. And I remember family, I remember food, I remember school. When I was 8 years old, my family traveled for a short period of time to Spain. And my cousin, who was living there at the time, she must have been in high school. She took us to her school to show us around. And she opened the room, and it was the lab, and it was full of lab glassware. And, it just caught my breath. I couldn't believe that such a fun thing existed. That memory of a kid in an empty lab has stayed with me for now many, many years. Eventually, I made the decision to become a neurosurgeon. And I remember very well that I spoke with a lot of people to ask their advice. And overwhelmingly, everyone pointed me to what was perceived as the negative aspects of neurosurgery. Long work hours, emotionally, physically, and intellectually draining. There were essentially 2 people that encouraged me to do neurosurgery. And at the end, I thought about this long and hard, and I decided to only listen to the 2 people that encouraged me. Many times in my career, both as I was training and also as a staff neurosurgeon, I've been the only woman in sight. Oftentimes, even in large conferences, I would take the time to look around, and in a crowd of over 100 people, I might be the one or maybe one other woman. Very, very few. I was the first woman hired at the Toronto Western Hospital when I started here as staff. And now there is 2 of us, Dr. Zadeh and myself, and there is a number of other women as well across Canada who are surgeons, scientists, and educators. The field moves slowly. What I do feel, though, is that every time someone takes a step, a woman takes a step in this area, we open the door for others. And the next door becomes a little bit easier. Another aspect of my life is being a mother to 2 daughters. Both of them are now at a stage in their life in which they are looking at their options for careers and their future. What I really try to deliver to them is to have a lot of passion for what they do and to know that they can do a lot. My message to all students, boys and girls, considering a science and STEM is by all means, if you have passion and if you have interest, pursue that interest. Don't be dissuaded by any negative thoughts that someone might put in your way. It's hard or it's long. It's fine. If you like it, it will be enjoyable and it will be, yes, hard work, but hard work is good work. If I had to go back and do it all over again, no problem. We'll do it again.
Good morning, everyone. It's so wonderful to be here. I'm Mosh Gan Hudai, and this is my story. You can see me here as a young girl. I never thought when I was that age that I would end up doing what I'm doing today. But I was moved by a sincere curiosity in science and what was happening in the natural processes of the world, and also a big desire to help humanity. And that is what ultimately led me to medicine. You can see me here on the day that I graduated from medical school with my parents. And what actually led me to become a neurosurgeon is that my father needed to see a neurosurgeon. His English was not very good, so I would take him to his appointments. And through that, I got to meet some amazing people that helped me with my choices and my career and became mentors to me and taught me not only how to understand science, but how to be a scientist as well. And through those connections, I ended up as a neurosurgeon and as a scientist. So I get to work with the brain, I get to image the brain, such as the images that you see here. And I get to do a couple of really, really cool stuff that I wanted to share with you. One of them is looking after a severe pain condition called trigeminal neuralgia. And this is a really severe pain that affects the face of patients with what is like a very severe thunderbolt of pain that hits them unexpectedly. So imagine, for instance, that you're just having a sandwich, or you're brushing your teeth, or simply you're smiling and you get hit with this very, very severe pain. Most of you think of pain that is associated with surgery as something that comes to patients after they have an operation. Patients that have trigeminal neuralgia have a very severe pain before the operation, and I operate on them to get rid of this pain. This condition also allows me to study the brain and look at images of the brain, such as an MRI that you see here, and examine these images to understand what is happening in the brain when patients have these type of severe pains. And what we do is that we process these images with really fancy computer programs and look at specific fibers and study these fibers to find out what is going on when a brain has pain. And we get to look at the brain in really, really cool ways, imaging the highways and how different parts of the brain can connect to each other, and looking at these really beautiful pictures and drawing also important measures that allow us to understand what is happening in this brain. And recently, I completed 1,000 operations for this condition, which really highlights our hospital as the key site in Canada where this condition is treated. Another aspect of my work that is really important to me is surgery across the globe. So when we think of surgery and how every person across the globe has access to it, there's quite a lot of disparity. And the disparity is such that 75% of the population of the world really has access to about 5% of the surgeries that are performed every year. So I want to change this. I want to make sure that when a child has a brain tumor in Africa, or a grandfather gets hit by a car in Vietnam, that they have as good a care for their surgeries as we provide them here in Toronto. And this is what has led me to champion the area of global neurosurgery. So this has taken me to places such as Cambodia, where I work with the doctors there that are training to be neurosurgeons, to help them develop stronger programs to help their own people. I've also gone to places such as Indonesia to help them with unique operations that they may not be quite familiar with, and help them again gain that strength to develop stronger surgical services for their patients. And you see me here in Cambodia again with the team there. The girl that is sitting right beside me is the first neurosurgery resident that is a woman there, and she will be the first of many, because as they grow and they become stronger, more and more women will follow her lead and learn to do these operations and these techniques in that country. So when I think of where I was and how my life has developed, there is no doubt I had no idea that I would end up doing what I'm doing today, but I'm so grateful and so happy about the road that I took with science and where it has led me. And I think when we look at young girls and when we look at young children, we may not really think where it is that they would end up. But the important aspect of this work for me is that we really want to develop a space that allows people, allows children to grow and develop the very deep sense of passion that they might have for the world, to move their ideas forward and allow them to be powerful scientists and powerful clinicians and powerful people in STEM to help champion society and help champion causes that allow for everyone to grow and develop their passions. Thank you so much again for this opportunity.
Thank you, Moshi. That was amazing and so very inspirational. Between the two of us, let's hope we've inspired a few future neurosurgeons who may be watching today. Next is Dr. Valerie Wallace, who is my colleague, Research Director of the Donald K. Johnson Eye Institute at UHN. In addition to her many other talents, Dr. Wallace also happens to be a talented seamstress and even makes her own clothes. I wanted to ask if her clothes today are handmade. However, let's watch the video and have her speak to us. Thank you, Valerie.
So as long as I can remember, I've always been fascinated by how disease happens in the human body and how a problem in one organ then creates this domino effect to get a whole other set of problems. When I was a little kid, I was very thirsty for knowledge, and I had access to my mom's university science textbooks. And we looked at that textbook for years, and yeah, we got gum between the pages. But I still remember, pictures of fossils, and I just thought, wow, that's amazing that, people were learning things, from millions of years ago and understanding the world that way. I had a fantastic high school science teacher, Anna Bowles, a chemistry teacher, and she was very, very funny, but everything she said kind of made sense. And she broke it down in a way that if you learned some of the rules and ways of thinking, you could predict what would happen in different new scenarios. And I think I thought that kind of problem solving was a lot of fun. I did biochemistry at the University of Ottawa, and then I was hooked. I learned about how proteins work and how they fold and how they interact with other proteins. And yeah, at a micro level, you think, what's that got to do with disease? And I would say it has everything to do with disease. What does a scientist do all day? I get asked this question a lot. So what my day typically is like is talking and discussing experiments and data with people in my lab. It's usually, Valerie, look at what I found. I don't know what it means, or I tried this experiment, it didn't work, or I'm going to try this experiment, what do you think? Also, the kind of science I do, many of the experiments end up in some way, shape, or form being imaged in a microscope. And I still find looking at cells and tissues so gratifying. What I'd say to anybody considering a career in STEM is that you have to throw away your preconceived notions about who is or who isn't a scientist. There is a lot of failures, there's setbacks, there's disappointments, and there are in any profession, but in science that's true. And another thing is, don't be afraid to ask questions. A lot of people won't put their hand up to ask a question because they think it's a stupid question. And what I've learned is chances are if you've thought of it, somebody else has too, so ask it. Ultimately, if we didn't have science, we wouldn't understand disease. And if we wouldn't understand disease, we wouldn't have treatments. We wouldn't have, in some instances, cures. And we wouldn't have a way to prevent disease. So I think that these advances are instrumental for keeping a healthy, active society. Good morning, everyone. Thank you all for joining us. My name is Valerie Wallace, and it's a real pleasure to be here today to be able to share with you some of the research that my lab does. So most of my career, I've been a developmental neurobiologist working in the area of the visual system. And what does developmental neurobiology, what do they care about? Well, we ask very fundamental questions about how the brain is made, how you get different parts of your brain, how you get all those connections made so that you can do things like think, have memories, control your muscles, breathe. And really important to me is how you sense the world and vision. And I got hooked on this. Like many people, I never knew I would end up working in this area, but I got really hooked the first time I ever looked through the microscope at a piece of the retina. And what you're seeing here is a retina where all the cell bodies of the different cell types, and there are 8 cell types, are stained blue, and they're arranged into 3 different layers we call cell layers. And sandwiched in between those layers are little processes where these neurons connect with one another, and that's really important for how they communicate. Another really important reason why you want to study how the brain develops is because if you ever want to fix something, it's really helpful to know how it's made, and that's going to be important later on. So the retina is actually part of your brain. When I started this, I didn't know that, and it forms the first part of a really important circuit where the retina that's at the back of your eye is ultimately connected to the visual centers of your brain. Your eye collects light, but how you see is because of what happens in your brain. And there's a real good reason to study this as well, is that there's a lot of people living in the world who don't have normal vision. They're either blind or have severe visual impairment, which impacts their lives. So how does the eye work? Well, your eye is a very complicated tissue, but essentially it's a camera. And what it does is light goes through the transparent front parts of your eye to be focused on that retinal tissue that sits at the back of your eye. And as I said, you've got these layers, and things can go wrong back here where you can get diseases that hurt your ability to see. So for example, diseases like glaucoma and diabetic retinopathy destroy the neurons in the inner part of the retina that connect to the brain. And diseases like age-related macular degeneration or inherited retinal degenerations target the photoreceptors. These are the cells that actually are the first line of vision. They capture light. And what does it look like for people with these diseases? So this is my lab as seen by somebody with normal vision, where you can see everybody very clearly. But with somebody with age-related macular degeneration, they start to lose their central part of their vision. And that's the part of the vision you rely on every day to read, tell the difference between colors, recognize faces. And eventually, having that kind of vision loss really impacts your day-to-day life because you're going to have problems with a lot of activities that you take for granted. Glaucoma is a little bit different. The visual deficits aren't in the center of your eye, but you have vision loss around the edges and you have gaps in your vision. And this is going to affect also how you go about your day-to-day life. And for example, this disease greatly impacts people's ability to be autonomous and to drive, for example. So we have lots of things about these diseases that we don't really understand. The two that I just showed you really are age-related conditions, but not everybody who gets old gets these diseases. So what's the difference between people who get these diseases and don't? Another thing we don't know is what's happening at the level of the retina itself. What's happening inside those cells during that disease? Like a toaster, you could say your toaster's broken, but unless you know which part is broken, how do you know what to fix? Could we develop treatments that could slow down the disease? That could buy people years of good vision. That would be really useful. Could we reverse the disease? And then finally, a thing to remember, like the rest of the brain, you don't really make new neurons once they die off. So when these photoreceptors die off, you don't replace them with any new ones made by yourself. So even if we could slow down the disease in some people, once those cells are gone, those treatment options wouldn't be good. So we need to find some other way to help people restore their sight after they lose those cells. And so we started to work on whether or not cell transplantation might repair the retina. And it's a really simple concept. Here's a normal retina with the layers, and we're going to talk about the photoreceptors. But in a diseased retina, those cells die off, and that leaves you with gaps. And so we've been asking the question, what if we transplanted, literally injected, healthy cells, healthy photoreceptors, and they're always going to look green in my pictures because we've engineered them to express a jellyfish protein called green fluorescent protein. And what would these cells be able to restore vision? And if they did, how would they be doing it? And one can imagine that in some scenarios, maybe these cells would kind of walk into the retina and actually replace those lost cells. So take up the, look like normal cells and replace the function of the ones that had died. But there's another possibility for how cell transplanting might work, is that, remember, you have some of these photoreceptors left, but maybe they're sickly and they also don't function as well. And maybe your transplanted cells signal to them to help restore their function. So that's like a cell-cell communication mechanism. So we've done a lot of work to try and understand what transplanted cells do after you transplant them. And we have things like, we can find our transplanted cells. This is a whole eye that's been transplanted with those green tagged cells, and you can see them on the surface of the retina. And this kind of imaging helps us locate our cells. Because you imagine there's a lot of places you could look, and you want to look, you want to find the spot that's going to tell you the most about what those cells are doing. And then when we look even more closely at these cells, what we find is our transplanted cells never actually walked into the retina below after we squirted them in. But in fact, they stay outside the retina. And they did something that we didn't anticipate at all. They form these finger-like projections that grow towards the host retina and attach to the host cells. So these are the cells that are remaining in our host retinas. And in some cases, they even transfer this green fluorescent protein. And this kind of transfer process really surprised us. Those proteins are supposed to stay inside cells, not go between cells. And we call that process material transfer. So we got a few surprises when we studied cell transplantation. And the way we think about it now was that our transplanted cells stay outside, stay actually where we put them. They don't walk into the retina, but they grow these long finger-like projections or connections that somehow stick to these host cells. And in some cases, even transfer the green fluorescent protein. So this is a rescue mechanism that's somewhere between those two scenarios I told you about. And this has raised a lot of questions. So what causes these protrusions to grow? How do they connect to host cells? What besides green fluorescent protein is transferred? So for example, if we ever did this in the clinic, we wouldn't have our cells tagged with green, but there's very likely other things that they're transferring. Are those things good or bad? Could these help restore the health of unhealthy neurons and lead to improving vision in a patient? And then finally, a really exciting question for me is, are cells normally doing this in the body? even in normal tissues or even in a disease. So by just starting some experiments, we ended up with new questions. And, I have to come back to the problem we're trying to solve. There's over 1.5 million Canadians living with vision loss, and we really need to do something to help them. I don't see patients directly, but their problems and the challenges they face in life are what really inspire me to do this work. And I wouldn't be able to do this without the help and partnership of a number of trainees who have worked with me over the years. I've had the privilege to mentor. They all came in very, very curious and wanting to do research, and have stayed in research because they basically developed a passion for understanding these problems and hopefully one day helping patients with these diseases. Thanks very much.
Thank you, Valerie, for that excellent presentation and such amazing images. I almost want to switch to retinal research. I can be a good postdoc if you're looking for one. Our final speaker this morning is Dr. Sowmya Viswanathan. She is a scientist at the Schroeder Arthritis Institute at UHN. You can often find Sowmya doing outreach as a scientist in the school in her daughter's class, and she also loves to read. Let's listen in for more on Sowmya's science journey.
So my path to becoming a scientist was not at all linear. In high school, I was thinking whether I wanted to be a writer. I was interested in writing short stories, poems. I was getting published, but becoming a writer was very daunting. I didn't really want to be a journalist. I loved biology as a child. I was very fascinated by how biology worked, but what to do with biology, right? How do you become a scientist? I didn't really know what a scientist did or what that job entailed or how you could turn it into a career. I was taking grade 12 physics, and our physics teacher was asking everybody in the class, what did you apply for? What schools are you applying for? And he's like, you applied for engineering, right? I'm like, no. And he's like, why not? I'm like, because you need to be good at math. And he's like, but you are. And I thought, no, I'm not. But it turned out actually I was. So I applied for engineering at Waterloo, University of Toronto, and other places, and ended up doing chemical engineering, and then went on to do grad school in biomedical engineering. And then that's when I really fell in love with the science, because I did something called stem cells. We all start from a single cell, which divides and forms this ball of cells. But these ball of cells can then become any cell type, right? They have that absolute freedom to become any cell type. But the decision that they take to make a particular cell type is a bit of a dance between themselves and other cells and the environment. And I was very intrigued by how they made those decisions. And that's really what I did my graduate school PhD in. And ever since that, there's been like no turning back. I've just really, really loved it. Yeah. What I love most about science is working with young people and seeing their brilliance. It's very exciting to work with young minds. They're so enthusiastic and passionate about the research. They share my own passion. Work endless hours. You have to if you are doing science and then you're passionate about it. You think science is very, you have to do this, you have to do it in a certain way, but it's not. It's all about thinking and coming up with ideas and then playing with those ideas. So it's a lot of play, it's a lot of imagination, it's a lot of creativity. This is not a job for me. This is what I do. It's my passion. I don't really consider it my job. This is who I am. My daughter is now in grade 9, and she has a lot of interest in acting and music and creative arts, and I think that's wonderful and important. But I'm like, keep your foundation. She's good at math, do coding. Keep options open and ground yourself in really good foundational training so that when you do need to make a choice, you've not boxed yourself in, right? So you do have options, because the world as we know it is changing so rapidly, especially post-COVID, the world is going to look very different. But we know that artificial intelligence and technology and science is going to play a very big part in it. So you want to have some stake in that big part, right? You want to be able to shape that. If you think you can't do it, I'm here to tell you that you can. Anybody can become a scientist. Even a writer, even a person who didn't think he or she was good in math can become a scientist. You can do it.
Hi, everyone. This is Sowmya. I'm so excited to be here with all of you virtually and talk a little bit more about being a scientist. I thought I'd start a little bit by sharing about my family. I come from a family of strong, independent women. My grandmother, my mother, myself, and now my daughter. My grandmother was born in a small village in rural India, in the south, which is very tropical. And she moved up north with my grandfather to a different climate, different language, different culture. She had probably a formal grade 5 education, but she's one of the smartest people I've ever known. She had street smarts. And she used that to adapt, to adjust, to cope, to survive, and thrive. She raised 7 children who were university educated with my grandfather. And she passed on this ability to turn adversity into advantage to them, including to my mother, who's pictured here. My mother left India and her home and family and moved to Canada. New language, new climate, new culture. Luckily for me, this sense of resilience has been passed on to me. And today I run my own research lab. So what is it like to run a research lab? Well, the front end is all about the science, ideas, experiments, hypotheses. But the back end is a lot like running a business. I'm an entrepreneur. I have to figure out how to fund the projects, how to manage projects, how to deliver them, how to sell them to and get minds excited. I do a lot of writing. I always wanted to be a writer. Well, I got my wish. But the best part is really interacting with bright young minds like yourself. They come with so much energy and excitement and new ideas, and we're able to convert them into experiments in the lab. Some of them magically do work. One of the areas of research that I want to talk to you about today is arthritis. Arthritis is joint pain. And this is caused because this cushion between our bones in our joints gets worn down. It gets worn down as we age, but it also gets worn down because of injuries or because of our lifestyle or our diet, which can cause inflammation. In fact, we're learning a lot of new reasons for what causes arthritis, and it's very painful. Imagine not being able to walk up and down stairs, or to bend down and tie your shoelaces, or to use your fingers to do up your buttons. Listen to this. 1 in 6 Canadians now have arthritis, but this number is growing. 1 in 4 Canadians in just 20 years will end up with some form of arthritis. Think about that. A circle of 4 of your friends, 1 of you could end up with arthritis. And this isn't just something that happens as you age. Young people get it all the time. You probably see professional athletes like Steph Curry having all kinds of knee injuries and other pain. This happens to professional athletes, but also to amateur athletes, actually anybody who plays sports. You can get an injury and it may not heal, or if you don't take care of it over time, it could lead to arthritis. Here's the problem. We don't actually have a cure or treatment for arthritis. We have a lot of ways to manage the pain, and eventually patients go on to get something called joint replacement surgery. Their entire joint or partial joint is removed, and a prosthetic one is put in place. But we do have some ideas, mainly from nature, about how we can use our own body and its cells to heal ourselves. We see this in nature all the time. Geckos and salamanders, if they lose their limb, they're able to regenerate them. They just grow back. We have this ability too. Think about your fingernails or your hair or skin cells or blood cells. We make new ones all the time. But we can't do this with all our cell types, and maybe not for cartilage. So the idea in my lab and in many other labs around the world is to take cells from one part of the body, very deep inside your bone marrow. We can extract them relatively easily, and we can grow them up in the lab. And then we can inject them back into these joints so that they can help reduce the inflammation, the swelling, and the pain, and also help with the cartilage repair. In fact, we did this in Canada's first clinical trial, and we got some very promising results. So promising, in fact, that we were cited as one of the top 10 research advances in 2019 by the Arthritis Society of Canada. How cool is that? But what does this actually mean? Well, we need to do more clinical trials. And clinical trials is just the name that we use for experiments that are done in humans, but that's very tightly regulated because there's lots of rules. And we have to make sure that the treatments are always safe and that they are effective. And if we can show that over and over again, then maybe we could delay or one day even eliminate this need for joint replacement surgery. Now that would be really exciting and regenerative. Now, when we did our trial, we did see that some patients responded really well and were back into their active lifestyles. But other patients, they didn't have as robust a response. And the big question is why? What's the difference between these populations of responders and non-responders? And can we understand the biology of this in the lab? Because then we could use that knowledge to help treat all of the patients. One idea that we have is that we could boost the cells that we're injecting into these patients. We can enhance them to create designer cells that would then work well in all of the patients, including the non-responders. Currently, the way we treat medicine is sort of like buying a one-size-fits-all t-shirt, but we know that we can get a lot more customized clothing online. And we can do that with medicine as well. We can fit and manipulate the treatment so it fits the patient much better. This would be personalized medicine and would be completely transformative and change the way that we practice medicine today. And I'm very excited that the work that's being done in my lab is going to be part of that innovation. But what really excites me is interacting with bright young minds like yourself. This is actually me in my daughter's grade 1 class explaining the concept of stem cells. That's a difficult concept for grade 1s. So I took jelly beans, different flavored jelly beans, to explain how the body has different types of cells and that they all have different functions. Kids loved it. And they still welcome me in their class when I come by. Who knows? Maybe I've inspired some kids with the jelly beans, and maybe they'll go on to become scientists, and some of them might even become stem cell scientists. So where do I want to leave you with? Well, my path to becoming a scientist and running my own lab wasn't straight, one. But I truly believe that regardless of where you begin, you end up where you should. So as my grandmother said, don't be afraid to take chances and try new things. She did, my mother did, and now I'm following their example. So my advice to you is find and follow your passion. Don't be afraid to take chances and try new things. You never know where your path may lead you. And if you're lucky, you may have a lot of fun getting there. Thank you.
Hello, my name is Dr. Eugenia Adi, and I am the Chief Executive Officer of Visions of Science. My message for you today is simple. Yes, you. I grew up my whole life always asking, who, me? When a new opportunity would come in STEM, I'd say, ooh, who, me? When somebody would ask if I was interested in it or if I wanted to be engaged in it, I'd always ask, who, me? And all of my travels and experiences have really taught me that my answer should have and is always going to be, yes, you. STEM needs you. Regardless of whether you see yourself in it right now, regardless of whether you're represented, know that simply by being you and by being in this space, you are changing the game. So if you have ever questioned if you should be a part of this, my answer is yes, you. I hope that you enjoy this event. I hope that you realize that it is one step of an awesome journey, and never forget it. Thank you so much, and I hope you have a wonderful day.
Wow, that was amazing. Thank you, Eugenia, for that inspiring message. So next time you think, who, me? Just remember Eugenia's advice and remember, yes, you, absolutely you. I also want to thank Dr. Sowmya Viswanathan for a really inspirational talk, and hopefully we can regenerate, just like a salamander, our brain, our eye, our joints, etc. And hopefully many of you in the audience will help us get there. So I'd like to now invite our speakers to join me in answering some questions submitted by local students. I have Sowmya, Moji, and Valerie with me. The first question is from Ms. Murphy's grade 6 class at Adelaide McLaughlin's public school. What type of education is required to become a scientist? Moji and then Valerie, please.
Sure, thank you for that wonderful question. So I'll speak about what's required to become a clinician scientist. So generally, there is training in medicine. So there's the years that required to become a medical doctor, following which there's a period called residency in which people specialize in their specific field of work. So neurosurgery, as it was for me. And then after that, or sometimes parallel to that, there is a dedicated time for a graduate degree, such as a master's or a PhD, that allows you to focus in the understanding and learning how to do science. And typically there is another step after that, which is called fellowship, where people focus in a very slightly narrower field of surgical work. So there are a few years that add up to each other, but then they allow you to combine everything that you've learned to become a clinician scientist.
Thank you, Moji. And Valerie.
Okay, so as a PhD research scientist, the path is a little bit different, but does involve a lot of education as well. Typically, you do a bachelor degree, a 4-year degree, and then you go to graduate school, do a master's, or maybe even convert that into a PhD. And that's where you really learn how to ask questions, do experiments. And then that's followed by a postdoctoral period. In my case, it was 4 years. Where I moved country and trained for another 4 years. And that's where you really master something that you're going to work on when you start your independent career. So all told, it's probably about 11 or 12 years from the time you leave high school until you become an independent investigator.
Thank you, Valerie and Moji. And I'll say it does take 10 to 12 years. They go by fast, and they're the best years of your life. So don't let the numbers prevent you from going into this field. The next question is from Ms. Gagliardi's grade 8 French immersion class at the Durham Virtual School. And this is for all of us. What advice would you give to your younger self? Great question. I'll start out with Sowmya.
Thanks. I probably have a lot of different advices, but I think one thing I would tell myself, because I was worried about career paths and what courses to take and what jobs. So I try to tell myself to stress less. Things have a way of working out.
Moji?
Well, I would say be positive, take action, and dream big. You really are driven by those dreams.
Valerie?
Great question. I'd have to say, I also say to myself, worry a lot less and take more risks.
Great. I would have to say I echo all three ladies, and I would add maybe just have more fun as you do everything you do as you go through life. Okay, I think we can have 2 more questions. Mr. Sullivan's grade 6 class in virtual school has posted a question to me. Who helped you when you were in tough times? And I have to say I had this question in advance and I thought a bit about it. Obviously many people. I would say the most important person that I relied on was my mother. She was a strong role model for me and continues to be. So if I have a problem, I keep taking all the information from many people I know, and I just use her as a sounding board. But I also use a lot of my colleagues and mentors, my peers, as sounding boards for coming up with the answers in tough times. So for example, if there's an issue that I need to solve, I try to get as many opinions as possible to then reach a conclusion for myself that suits me the best. So that would be my answer. The next question is from Madame Sloan's grade 6 class at Meadowcrest Public School for Dr. Hodaie. They would like to know, do you actually get to see the brain?
Wonderful question. Well, yes, we do actually get to see the brain. When we operate on the brain, we get to see it, we get to touch it. And a lot of the times we operate using a microscope because we want to be very accurate and precise and make sure that we keep the brain as safe as possible. But there's also one additional way in which I get to see the brain, and that is by using the type of advanced brain imaging that I showed. And that not only shows us many details of the brain that are not visible to the human eye, but allows us also to study specific regions of the brain or how some areas connect with each other. And of course, that helps us advance our research.
Great, thank you, Moji. And I'll have to say, I will add to Moji's answer that the brain truly is one of the most beautiful things that I've ever seen. I love seeing the structures in the middle of our brain when we operate. It's amazing. Mr. Jeff Wa's grade 6 class at Durham Virtual School asked, what sort of hurdles have you had to overcome as a female in the industry? For example, recognition, pay gaps, lack of opportunities, etc. Maybe I'll start with Sowmya and Moji.
Thank you. That's a really good question. Obviously, there's a lot of challenges. I think one of the ones for me was balancing family and personal life with workload and sort of how to manage that. I think that's true for both men and women, by the way, so it's not just for women. And I don't really have like a prescription answer for this, but what worked in my case, and I was lucky, is that I had flexibility, I had great mentors, and I had wonderful support network at home. So with all of that, I was able to achieve that balance. But I'm really conscious of that today. So when I have my own lab now, I try to create that flexibility for my students and trainees so that they too can balance kind of their family and personal life with their workload. Moji, thanks.
Yeah, this is a very, very good question. There's definitely barriers that we all faced in different ways, but I think for the group that are listening to us, you will face your own barriers. And although mine may not be the same as yours, they will be as important to you as they were to me. In my view, I think whatever barriers we come across, we have to face them with a measure of faith, patience, and courage. And think about the problem, try to break down larger problems into smaller ones, and bit by bit put them together as a jigsaw puzzle, and the road will become easier. Every time someone takes action, whatever problem we have, becomes a little bit easier for the next person, and that's really what we want to do.
Dr. Wallace, you're up next. Ms. O'Neill's grade 10 science class at Brooklyn High School has a question. All work has challenges. Tell us about the challenges that you face in your particular line of work.
All right, that's a great question. And maybe it's a challenge, not just in my lab or in, but it's a thing that I hear from a lot of students who are starting off in research, and that's the fear of failure. And I think we have a really strange relationship with failure. We're afraid of it. And we feel somehow kind of shame or feeling caught out. But I think you have to break it down. What is failure? And I think, as I say to my students, it's usually telling you something you don't know. So it's not really failing. It's just actually giving you more information. The scary part for students and a lot of people who face failure is that they didn't get maybe the answer they were expecting. So in a scientific experiment, you got a completely opposite result than what you expected. And students will come to me and say, I failed. And it's like, no, your experiment worked. You just didn't get the answer you wanted. And that's actually far more interesting because all we can do is ask questions and get an answer. And if it's the answer you weren't anticipating, people get scared because they think, oh my God, what do I do with that? And that's a time to sit, think, regroup, talk to people, and eventually you'll find your way forward. And I found that actually failure is probably the most exciting part of the job. Thanks for your question.
Thanks, Valerie. The last question is a fun question from Mr. Sullivan's grade 6 class. And the question is for all of us, if you were trapped on an unknown island, who would you bring? I'll start with Sowmya.
Yeah, wow, that's a fun question. I think if it was a really nice paradise island, then maybe I wouldn't want to leave. So I would want my daughter and maybe family there. So I could just, happily live there, maybe get the lab too at some point. But if it was one of these desert islands that I needed to get off, then I think I'd want someone resourceful and scientific, and a good understanding of engineering principles. So during COVID, I've been watching some retro cartoons and Looney Tunes especially, and I've been watching Wile E. Coyote a lot. So for those of you who don't know, he's desperately trying to catch the Roadrunner, and he uses all of these really neat contraptions and devices, and actually an astounding understanding of physics principles and science. Now, he never catches the bird. That's the premise for the show. But maybe without the bird being there on the island, because this is completely hypothetical, he would be successful in helping us off the island. So that's probably who I would choose.
Valerie?
Thank you for that question.
Well, there's lots of possible people, but I think I have to say, first and foremost, I would bring my barista, because as my children will tell you, I can't start the day without my latte, and it's better for everybody around me if I've had my coffee. So that's who I'd bring.
Moshi?
Well, I guess it would depend on whether I plan to stay and live in that island or get out. I think I'll probably want to get out. I'm a huge fan of science fiction. And based on what I've watched last, I think The Mandalorian would be a good choice. He would probably get me out of there pretty quickly.
I would have to have my 2 daughters, good or bad island, and I hope that my island is close to Valerie's because I have to have that coffee too. Okay, everybody, I want to thank all of you for joining us today, and we hope you enjoyed the stories, the presentations, and the insightful discussion. Most of all, we hope you feel inspired and excited about the possibilities that await you. I do have to thank the Krembil team. Without them, this would not be possible. Carly McPherson, Heather Sherman, Twain Pereira, and Amy Ma. They organized the whole program today, prepared all of us, and had us ready for the Durham District School Board, and your partnership has been amazing. A quick reminder that today's event was recorded, so if you know of anyone who missed it live and would like to see it, feel free to pass the link along. Excuse me. And finally, before you go, I'd like to leave you with a challenge. From this moment forward, try not to ask yourself what you want to do when you grow up, and instead think about who you want to be. Which problem do you want to solve, and how will you get there? Be well and stay safe, everyone. Thank you for your time, and feel free to reach out to us. Have a good day.